Hi viewers, so welcome back to the channel. So in the previous videos we have discussed about volumes of combination of solids. So here we are going to discuss some more problems related to that. See example 11. So what he has given, a cylindrical container is filled with ice cream whose diameter is 12 centimeters and height is 15 centimeters. The whole ice cream is distributed to 10 children in equal cones having hemispherical tops. So you might have seen the shape of an ice cream cone, right? So this is nothing but that particular thing that is given. So if the height of the conical portion is twice the diameter of its base, so find the diameter of the ice cream cone. So it's asking you to find the diameter of the ice cream cone, right? So how to do? So how to do this particular problem? So let us see this. So there is a cylindrical container. So there is a cylinder. So in this cylindrical container, the diameter is 12 centimeters. That means radius is 6 centimeters and its height is 15 centimeters. So this is filled with ice cream. So this total ice cream has to be shifted into this particular shaped cone ice cream, right? So this ice cream that is present in this particular cylinder, we need to fill into 10 ice cream cones. So from this what you have understood? That means the volume of this particular total cylinder we need to fill into 10 ice cream cones. And what he has given? Height of the conical portion. So height of this cone is equal to twice its diameter of the base. Is equal to twice the diameter of the base. So from that we need to find out the diameter of the ice cream cone. So regarding this cone I need to find it out, right? Now first of all, so what are the things that are given? So about cylinder, radius of cylinder is given as, so since diameter is 12, radius is 6 centimeters and height of cylinder is 15 centimeters. So these are the things what we have, right? Next, what we need to find it here? So regarding this cone, he has mentioned something, right? If the height of the conical portion, so height of cone is equal to what he has given? Twice the diameter of the base. Twice the diameter of the base. Twice the diameter of the base means diameter is represented by 2r, no? So height of cone is equal to 2 times of r. So this is nothing but my diameter, right? So 2 into 2r, which is nothing but 4r. So I got height of cone, which is nothing but equal to 4r if radius of the cone is r. So from this I can say radius of cone is equal to radius of hemisphere is equal to r. If radius of cone is equal to radius of hemisphere is equal to r, then height of cone is 4r. Now what is he asking you to find? Find the diameter of the ice cream cone. So diameter of the ice cream cone means I need to find out the value of 2r. So this is the thing that I need to find out. Okay, remember this. Now what he has given? So this particular cylindrical volume is shifted into 10 such volumes, right? So from this what I can say? So volume of cylinder is equal to 10 into volume of cone plus volume of hemisphere. Because this total thing, whatever the thing that is there, that is distributed into 10 such shapes, no? Since it is combination of solids, so we can take directly the volume of those things. Now volume of cylinder. So what is volume of cylinder? Pi r square h is equal to 10 times of volume of cone is nothing but 1/3 pi r square h plus volume of hemisphere. It is nothing but 2/3 pi r cube. Now I am going to substitute the values, so one after the other. So in all the things I can cancel out pi because all the terms contains pi's, right? Now first on the left hand side what do we have? About cylinder, no? So we are going to substitute the values of cylinder. So 6 into height of cylinder is given as 15 is equal to 10 into, so here by 3 is there, so directly I am taking it out. So 10 by 3 into, so r square h. So radius of cone, so radius of cone I have considered it as r square only into height of cone. So height of cone I have considered it as, so 4r, right? So it is 4r. So then this is 4r plus, here already 3 I have taken it out, so 2 into radius of cone I have considered, so radius of hemisphere also I have considered it as r. So from this what I am going to find out, so don't multiply this, okay, so don't multiply. So what I am going to get, so 6 into 15 into this 10 by 3, if I transpose it becomes 3 by 10 is equal to, already this is r square into 4r is nothing but r cube, sorry 4r cube, so 4r cube, and this is 2r cube, so 4r cube into, so 4r cube plus 2r cube gives me 6r cube. Now on both sides I can cancel out 1 6. Next in 5 table this goes 3 times and this goes 2 times, right? Again this 2 in 6 table, in 6 it goes 3 times, so clearly r cube is equal to 3 cube only, no? So from this radius is equal to 3 centimeters, so radius is 3 centimeters. But what did he ask? So he asked to find out diameter, no? So diameter of ice cream cone, so diameter of ice cream cone is equal to 2 times of radius, so which is nothing but 6 centimeters. So have you understood? So here already we know, so to fill the ice cream into a cone, so first it will be stored in some cubical shape or cuboidal shape or cylindrical shaped containers. So here the same question is given, so from that container, so we are going to exactly fill 10 such cones. So how the cones are filled? So cones are filled in the shape of a cone with a hemispherical top, so with a hemispherical top on it, right? So from this what I can say, volume of cylinder is equal to 10 times of volume of cone plus hemisphere, because this volume of cone plus hemisphere is nothing but my combination of solid, right? So based on that, so by using the simplification concept, so by the concept of volume, so we have applied here and we got diameter is equal to 6 centimeters. So the volume of this particular cone is 6 centimeters, right? Next, moving on to one more question. So what is next question? So moving on to one more question. See, a solid consisting of a right circular cone standing on a hemisphere. See, from the figure you can easily understand. So already what we have discussed earlier, the same thing he has given in some other way, right? A solid consisting of a right circular cone standing on a hemisphere is placed upright in a right circular cylinder full of water and touches the bottom, right? So it is touching the bottom. Find the volume of the water left in the cylinder. The same model, right? So if you observe in this cylinder, this particular shape is immersed, right? So when it is immersed into this cylinder, so what? So some water will be spilled out, no? He is asking you to find out the volume of water that is left inside. So find the volume of water left inside the cylinder. So from this what we can say? Simply volume of total cylinder minus volume of this particular shape. So this particular shape volume we need to find it out, right? Now what are the things that are given? First you write down. So first about cylinder we are going to discuss. So what about cylinder here? So about cylinder what he has given? So radius of cylinder is given as 3 centimeters. So this is nothing but radius of cylinder. Next, height is given as 6 centimeters. So height of cylinder is 6 centimeters. Next, what he has given about hemisphere and cone. Hemisphere and cone. So first of all, radius of hemisphere. So already we know radius of hemisphere is equal to radius of cone. So which is given as 2 centimeters. Next, height of cone. So height of cone is given as 4 centimeters. Right. So these all are the things that are given. Now what I need to find? So volume of water left. So what is the amount of water left? So directly what we can say? So amount of water that is left inside this particular cylinder is given by, so volume of total cylinder minus volume of that particular solid, so that particular combination of solid. So this particular combination of solid is nothing but volume of cone plus volume of hemisphere, right? So this particular volume of solid is given by combination of these two solids. So directly what I can write, so volume of cylinder is nothing but pi r square h. So since these are the terms of cylinder, so we are going to keep the suffix cy. Next, minus volume of cone plus volume of hemisphere. So volume of cone plus volume of hemisphere is nothing but 1/3 pi r square. So this is radius of cone and height of cone plus volume of hemisphere. This is given by 2/3 pi r cube. Now when I substitute the values, so this is 22/7 into here radius of cylinder. So radius of cylinder is 3. So 3/1 into 3/1 into height of cylinder is 6. So it is 6/1 minus, here this becomes 1/3 into 22/7 into what is radius of cone. So radius of cone is 2 centimeters. So 2/1 into 2/1 into height of cone is 4 centimeters. So 4/1 plus, next here 2/3 into 22/7 into what is radius of cone or radius of hemisphere, it is given by 2 cube, which is nothing but 8/1. Now cancellations. So what are the cancellations that are possible? So 7 cannot be cancelled, so directly you are going to multiply the things, right? So since we cannot cancel the 22/7, so from all the things I can take common 22/7. So then what I am going to get? So 6 3 is 18, 18 3 is 54 minus, here 22/7 I have taken common, here also from here also I have taken 22/7 as common. So 2 2s are 4, 4 4 16. So this becomes 16/3 here. So again minus only, no. So here 22/7 I have taken common. So 2 8s are 16/3. So 16/3, 16/3. So this becomes 22/7 into, so 16 16 32. So this gives me 54 minus 32/3. Now 54 3s are. So what is the value of 54 3s? So this gives me, so what I am going to get here? So 350s 150. So 162. 162 minus 32 is nothing but 130. So this gives me 22/7 into 130/3. So on simplification, so what I am going to get? So this particular value I am going to get as 136. So 136.19 centimeter cube, right? So when I multiply 22 into 130, I am going to get 2860 divided by 21. So when I simplify this, I am going to get the volume of the given water present inside that particular cylinder is 136.19 centimeter cube, right? So this is nothing but, so one of the important problems in this chapter, right? Next, going to one more problem. So what is that? See, a cylindrical pencil is sharpened to produce a perfect cone at one end with no overall loss of its length, right? So already we know, so how we are going to sharpen the pencil, right? So we will keep the pencil inside the sharpener and we will turn so that we are going to get the tip of the pencil, right? Now here what he has given is, so he has sharpened in such a way that the length of the pencil remains same. Okay, next he has given the diameter of the pencil is 1 centimeter and the length of the conical portion is 2 centimeter. Calculate the volume of the shavings. That means after sharpening the pencil, so you will be getting those wooden particles, no? So those particles are nothing but we call them as shavings, and is asking you to find the volume of those shavings, and is asking give your answer correct to 2 decimal places. If it is in decimal, use pi is equal to 355 by 113, right? So it is nothing but 22 by 7 only, which is multiplied with some constant, right? Now what is the thing that we need to do here? Now before sharpening the pencil, so how it looks? So it will be looking like this particular cylinder only, no? So it looks like cylinder. Okay, so after sharpening we are going to get this particular shape, right? That means, so what is the shaving here? What is shaving? So shavings are nothing but, so volume of cylinder minus volume of cone, right? So volume of shaving is nothing but volume of cylinder minus volume of cone. See here, so before shaving, so before sharpening the pencil, so it looks like this, so which is having, so he has given height of the pencil, no? So height of the pencil is 2 centimeters. That means this is nothing but, so this particular part we are representing here. So observe carefully. Now this is having height 2 centimeters. So remaining part we are not discussing, right? Only we are discussing only about this particular part. Okay, so this is 2 centimeters, and when we sharp it, so how it shape forms? So it shapes forms like this, right? So this is nothing but my conical shape. That means while sharpening, what happens? So this particular part and this particular part will be removed. So what is asking you to find? So you need to find out these particular parts, so which I am shading here. So these particular parts I need to find the volume. So how can you find that? So how can you find the volume of that particular parts? It is nothing but given by volume of cylinder. So before sharpening the pencil, what is there here? Here we are having a cylinder, and after sharpening, what is left over? So we are left over with a cylinder, so a cone, right? So what is lost here? So all what we lost is nothing but the shavings, right? So from this what I can say? So volume of shavings, so volume of shavings is equal to, so volume of shavings is equal to volume of cylinder minus volume of cone. Volume of cylinder minus volume of cone. Now first of all we are going to take the values for cylinder. So what is the height of cylinder here? So we should not consider the whole pencil height, right? So we need to consider only the portion where we have sharpened. So height of the cylinder is given as 2 centimeters, and next, so here diameter of the pencil is given, no, 1 centimeter. So from that radius of cylinder is 1 by 2 centimeters. So we got details about cylinder. Next, talking about cone. So about cone, what is the thing? What are the things that are given? So height of the cone is given, no. So height of the cone is same as height of cylinder. So HCM, height of cone is 2 centimeters. So what about radius? So radius also nothing but the same as cylinder, right? So radius of cone is also half centimeter. Now directly, so this volume of shavings is given by pi into r square h suffix cy minus 1/3 pi r square h. Here suffix co, here suffix co. Now since height of cone is equal to height of cylinder, radius of cone is equal to radius of cylinder. So that means these are only the two variables that are present in both the formulas, right? So directly what I can do, pi r square h minus 1/3 pi r square h, which gives me 2/3 pi r square h. So directly by simplifying this value we are going to get the answer. So which gives me 2 by 3 into, what should I take the value of pi? So pi I should take it as 355 by 113 into, what is the radius of the cylinder or cone? So both are 2. So 2 by 1 into 2 by 1 into, what is the height of, sorry, this is radius, no? So radius of cylinder is 1 by 2. So 1 by 2 into 1 by 2 into height of cylinder is 2 by 1. So from this what I am going to get? so 2 gets cancelled. Next this 2 and this 2 gets cancelled. Now 5 plus 5 10, 10 plus 3 13, so we cannot cancel in 3 table, right? So 355, so what I need, so 355 divided by 3 3s are 9 and this is 339. So 355 divided by 339. So on simplification, so what I am going to get is, I am going to get, so 1.05 centimeter cube. So this is nothing but my volume of shavings, because so shavings, that is nothing but the waste particles which we get after sharpening the pencil are very small in quantity, right? So that's why we are going to get very small value, so which is nothing but 1.05 centimeter cube, right? So this is nothing but the answer. So likewise, so we can find out the volumes of combination of solids. So when we are removing, we need to subtract. So when we are adding, we need, so when we are combining the solids, then we need to add those volumes, right? So I hope you have understood the whole concept and the problems related to this particular concept, right? So in the next video we are going to discuss about the conversion of solids. Okay, thank you for watching the video. So thank you very much.